Welcome back to our discussions of JavaScript. Today we're going to look at a couple of JavaScript array transformations that turn out to be extremely useful. So we're going to look at map and filter, and I have my JavaScript code here and my browser on the left as usual. I have map here. Map calls a callback function for each element in the array. So the callback function then can provide two parameters: the value of the object, and then second, the index in the array. So here I build an array of numbers. Then I'm going to call map against those numbers. Numbers.map, and here's the callback function. Notice it's an anonymous function, that is a function without a name. And here are its two parameters. The first parameter being the value at the index, and it's going to march through them in order: 0, 1, 2, etc. So the first call is going to be 1 at 0, and then 3 at 1, etc. So let's refresh the page here. I have my console tools open here, and notice here output 1, and I've built this array of 12 results, essentially transforming these individual numbers into this array that contains this string value, specific value found at the index. Here we have the results here. So what you expect with map is that if I have n numbers in the input array, then I have n results in the mapped output array. It doesn't, by the way, change the original numbers. That's still in place. It numbers calls a callback function, and it builds internally a collection. And then when the collection is finished, that is it's done iterating through all the numbers or all the objects in this array. Then it returns with the mapped array, 1 to 1, 12 elements in, 12 elements out. So this uses kind of old syntax with the explicit anonymous function, really, a function without a name here. Okay. So what you see going to be in modern code all over are arrow functions, and once you get used to the syntax, you'll see why. Here it's the same idea: a callback function, two parameters, and then the body of the callback function on the right hand side of the arrow. If I put curly braces here, I could do that if I needed multiple lines of code, then I needed an explicit return type. But if I have a simple JavaScript expression here, I don't need a return statement or anything else. It simply takes on the values of this, and you can see it's going to be the same result of the output. So output 2, same results, but using the arrow function, which most people find it cuts down on the verbosity of what you have to express, right? It's more direct. I think it's a more direct expression of the logic. All right, so we saw map, which is a one-to-one translation. Now, what filter does is it says, does it pass this test? And if it doesn't pass the test, then it's not in the result set. So it's similar to map, and then the filter is going to iterate over all objects it finds in the array. It's going to call a predicate function. Remember, a predicate function is a function that returns a true or false value, so it's expecting true or false. If the predicate function returns true, then the object belongs in the result array. And if it returns false, the object does not belong in the default array. Notice what we do in numbers filtering, and you can read this code, I'm sure. It's going to filter for even numbers. So if the number is evenly divisible by 2, it belongs in the output array. And here we have output even numbers, and we can see all even numbers in that output. And here we filter also using an arrow function, but not equal to 0, therefore for odd numbers, and therefore we filter and get an output of odd numbers. Again, numbers is not affected. Output is the resulting array. So now we have map, which allows us to map input values to output to a different output value, 1 to 1, and filter, which allows us to reduce the numbers in the array. If you combine the two, you get some real power. So numbers.filter for odd numbers, and then .map to transform those only odd numbers into the results. So odd numbers mapped. And here we have similar results to the first calls to map that were unfiltered, but now we're filtering it first and then mapping it later. So you can filter for your output. So imagine a stream of data coming from the server. It may be raw data. You want to format it for the user input. map is perfect, right? Filter and then map, and then essentially condition the output, get it ready for the user interface. So the last result, I'm going to invent a class called student with an ID and then toString. Okay, so what numbers.filter? I'm filtering for even numbers, and then I map to a new student record. So in this case, in the previous case, I was transforming to a string or mapping into a string. This time I'm mapping into an object after first filtering for even numbers. So here's my mapped array of students with even number student IDs here. And then, you can see it's mapped to a JavaScript object. Right? So we did new student here, not just a simple string. Okay, so that's our output there. And then we filter, actually, output.filter is equal to output. So here we are replacing the value of output, and we're filtering for student ID. Now the parameter, I just wanted to give a different type of parameter here. So output is now not just an array of numbers, but an array of student objects. And now we can decompose that into the object properties because this object S is a student object here that's passed here. So any student properties that happen to be in there, we can use and filter for and map to. So here's our students then mapped who have student IDs of greater than 10. Okay, so again, map and filter, very useful, as we'll see immediately in user interface code. Thank you.